Okay, today's lesson is 12-2. We are evaluating limits algebraically. So before in 12-1, we used graphs and tables to estimate limits, and now we are going to use computation. So the first two functions that I want to talk about are the constant function and the identity function. So your constant function looks like this. That's basically y equals a number, okay? And we're going to say that the limit of that function as x approaches c, the limit of k equals k. So if k was equal to 2, then the limit as x approaches 4 of 2 equals 2. Anywhere on this line, no matter where I'm going, as I get closer to that value, in this case I just said 4, then it's going to be 2. Okay, the other function is our identity function, which you might know it more easily as y equals x. Okay, that's our identity function, and it would be the limit as x approaches c of x is equal to c. So no matter what, the limit is as x approaches -3 is going to be -3. So what's really important about that, actually, before we go there, let's talk about some properties of limits before I talk about the other most important thing about it. Okay, so we have some properties that make our evaluation of limits quite easy. The first one is your sum property, and it says the sum of the limit of a sum is equal to the sum of the limits. Next, we have the difference property. The limit of a difference is equal to the difference of the limits. Then we have something called the scalar multiple property. That says if you're taking the limit of a number times a function, then you can bring that number out and multiply it by the limit of the function. It makes it a little bit easier in your calculations. Okay, we have the product and the quotient property. The limit of a product equals the product of the limits. Limit of a quotient equals the quotient of the limits. Remember, the denominator cannot be 0. We have the power property and the nth root property that go together. So when you're taking the limit of a function to the nth power, you can go find the limit of the function first and then raise it to the nth power. Likewise, you can go find the limit of the function and then take the root of that function, of course, when n is even, because we cannot take the square root of a negative number, or fourth root for that matter. Okay, so the next type of function, limits of polynomial functions and rational functions. This is the basis of what we're doing to begin with. We're going to learn some tricks as we go along, but it tells you a polynomial function, if y'all remember, something like that, to follow my graph, smooth and continuous. The limit as x approaches c of p of x equals p of c. Okay, or if I have a rational function, remember that's the fancy word for a fraction. Okay, the limit as x approaches c of r of x is r of c, which is p of c over q of c. Okay, what is key? What is happening here, y'all? Well, actually, I'm going to say it down here. Limits of polynomials and rational functions can be found by direct substitution as long as the denominator at c does not equal 0. So I'm going to be talking about this a lot, is basically you're taking this value. Whoa, I forgot I had it so fat from a previous lesson. Okay, you're going to take this value of c and you're going to plug it into your function, which is why we end up with p of c. So main method that we're using is something called direct substitution. So let's go look at some examples. Use the properties of limits to evaluate each limit. So as I said, you're going to take, if we have the limit as x approaches 2 of negative x cubed plus 4, I'm going to take 2 and I'm going to go plug it in for x. So that is -2 cubed plus 4. Remember, if you will always put parentheses around your variable, then you won't have any trouble. Put it directly in your calculator and you'll get an answer of -4. Okay? The limit as x approaches 2 of x minus 3 over 2x squared minus x minus 15. How many different x's do I have in there? 3 of them. So I've got to put it in 3 different places, and you'll see me write that. I'm plugging a 2 in for x everywhere I see it, putting parentheses around it. Makes it easy to see what I've plugged in. Put it in your calculator, and it will simplify it for you. Okay, use that horizontal fraction bar, or you have to remember to put grouping symbols around your numerator and denominator. Okay, last one, limit as of this type. Limit as x approaches -1 of the square root of x plus 3. Again, plugging in -1 for x is going to give me the square root of 2. And that's what we have. Okay, so some more direct substitution. Use direct substitution if possible to evaluate each limit. If not possible, explain why or why not. Okay, so again, everywhere I see an x, I'm going to plug in 4 because the limit as x approaches 4 of x cubed minus 3x squared minus 4x plus 7. Always the first thing you want to do is try direct substitution. So I'm putting it in, showing parentheses where each variable was, and then I'm going to simplify it and get an answer of 3. Okay, limit as x approaches -5 of x plus 1 over x squared plus 3. Again, plugging in -5 everywhere I see an x, putting parentheses around. Most important when you plug in a negative number, like we did up there with -1. Simplify it, and we have 1 over 7. The limit as x approaches -8 of the square root of x plus 6. Again, plugging in -8 for x, the square root of -8 plus 6, need those parentheses, and that's the square root of -2, which y'all know is not a real number. So in this case, we're going to say D and E, which we talked about previously. That means the limit does not exist because it's not a real number. Okay, so sometimes when you plug in and use direct substitution, you get an indeterminate form of 0 over 0. Then you need to simplify the expression algebraically by factoring and then dividing by a common factor. So might have to come down a little bit on this because it's I had wrote some stuff over to the side. So I have the limit as x approaches -2 of x cubed minus 3x squared minus 4x plus 12 all over x plus 2. So when you have a rational expression like this, the first thing you do, again, direct substitution, but really what you're worried most about is the bottom because I can't divide by 0. So if you put -2 in here, y'all, you get 0, and that's a problem. So what options do we have? We have to simplify that expression, okay? So at first I came over here and I factored it. Let me see if I can scoot that over because it looks like I cut off just a tad there. All right. Factor by grouping means I grouped the first two together, took out a common factor of x squared, grouped the last two terms together, took out a common factor of -4. And then it becomes that because I have a common factor of x minus 3. And then x squared minus 4 is x plus 2, x minus 2. So this top up here simplifies or factors, to this. Okay. And when I factor that, okay, you now have a common factor of x plus 2 on the top and the bottom. Okay. Now I'm going to tell you another way in case you don't feel comfortable with factoring. You can do long division, or if y'all remember, synthetic division. Okay. And you take -2 and you write the, this top row is the coefficients, 1, -3, -4, and 12. And then I start doing my dividing. Okay. Real quick, you bring down the 1, -2 times 1 is -2. You add, and then you multiply diagonally and add, multiply. So that means that this factors, that the numerator factors to x plus 2 times x squared minus 5x plus 6. Now, that is acceptable. So you can use it in this form or you can use it in that form. It does not matter. I happen to use it in the one that's already multiplied out. So again, I'm going to go back to direct substitution now because I don't have a fraction and I'm not going to have 0 in the bottom. So when I plug in a negative number, I always want parentheses around it. Simplify that and I have 20. So the limit as x approaches -2 of this rational function is 20. Okay, here's another rational function. They're both quadratic. So hopefully that's a little bit easier for you to factor. So the top factors to x minus 6 and x minus 1. The bottom factors to 3x plus 7, x minus 6. So these two are the same. And now when I do direct substitution, I have the limit as x approaches 6 of x minus 1 over 3x plus 7. When you plug in 6 for x, it looks like that, which becomes 5 over 25, which becomes 1 over 5. Okay? Now, I didn't talk about it so much up here, but this particular pattern, y'all, x squared minus 4, factoring to x plus 2, x minus 2, is a very, very important concept. Okay? We refer to it as a plus b, a minus b, or it's called the difference of two squares. A squared minus b squared are two squares. And the factors a plus b and a minus b are called conjugates. Okay? So whenever you have a radical, okay, in your problem, and that radical can be in the bottom or it can be in the top here, then what you're going to do and think about doing, okay, and I say this, y'all, because if you put 25 in here, square root of 25 is 5, 5 minus 5 is 0, I end up with 0 on the bottom. This one, they want the limit as x approaches 0. Well, again, I have 0 on the bottom. So that's a problem. And when you do that and you have a radical in your problem, you're going to multiply by the conjugate to move that radical. So, and I say multiply the conjugate. So the conjugate is back over here. They look exactly the same except for you change the sign of the second term. So the one that has the radical is the one that I'm worried about. So I'm going to multiply my top and bottom by the square root of x plus 5 over the square root of x plus 5. And what I'm going to get on top is those two things multiplied, x minus 25 times the square root of x plus 5. But on the bottom, you're going to get a squared minus b squared. So it's going to look like this, because the square root of x times the square root of x is x. And this negative 5 times positive 5 is negative 25. So that is this concept over here. Makes your problem a lot easier when you're trying to multiply things out. Okay, so you want to remember that. I've been saying it for a long time. So now at this point, I have a common factor here and here. And so I'm left with the limit as x approaches 25 of the square root of x plus 5. Direct substitution is going to make it look like that, because I'm going to plug in 25 under my radical. Square root of 25 is 5 plus 5 is 10. Okay, last problem. The limit as x approaches 0 of 2 minus the square root of x plus 4. Square root of x plus 4 all over x. So again, I'm multiplying by the conjugate of the term that has the expression that has the radical. So my conjugate is going to be 2 plus the square root of x plus 4 over 2 plus the square root of x plus 4, because you always have to multiply the top and bottom by the same thing. So when I do that, it's going to look like this. Okay, so I have, move that out of the way. On the top, I squared the first term. 2 squared is 4. And when you square this radical, the radical goes away, which is what we've seen before. So on the top, I end up with 4 minus the quantity of x plus 4. And on the bottom, I'm not multiplying that out. I'm leaving the x and then the rest of it. Okay. When I simplify the top, you've got to remember to distribute the negative. So you end up with just negative x on the top, and on the bottom, x times that quantity of 2 plus the square root of x plus 4. And now, if you will notice that there is an x on the top and the bottom. So what's left, again, is the limit as x approaches 0 of negative 1. Okay, so be careful of that, because a lot of y'all would want to move this to the top. It's in the bottom. It's got to stay in the bottom, which is why I have the negative 1 on top. And now I've got it simplified so that I can directly substitute 0 in for x, and I will have negative 1. Whoops, go away. Negative 1 over 2 plus the square root of 0 plus 4, which becomes negative 1/4. That is the end of 12.1a. If you have any questions, please don't hesitate to set up a Google Meet or email me. Thank you so much, and y'all have a great day.